Welcome. I'm Phoebe Goh, Principal Architect at NetApp, and it is an absolute pleasure to host today's Kubernetes Ecosystem Partner Roundtable discussion, or what I prefer to call Everyday Kubernetes with Really Smart People. Before I start, I'd like to thank our partners for joining me today to talk Kubernetes and some of the opportunities and challenges facing companies who are looking to embrace the next generation of cloud computing. As the popularity of Kubernetes has grown, we're seeing more and more applications that were previously considered not really viable for containers landing in its welcoming arms. This is because of both features that the Kubernetes community has built and also that our partner ecosystem provides. We continue to see rapid and incredible innovation, both here at NetApp, where our contribution to the ecosystem is part of our lifeblood, and also from our partners, including those of whom have joined us here today. So today's panel will talk about the Kubernetes evolution, some of the opportunities, and how companies and their tools and services have evolved to support business-critical and mission-critical applications in Kubernetes. I'd like to start by introducing our roundtable panelists. So why don't we start with Peter Z, CEO of Percona. Could you introduce yourself and a little bit about Percona and what your company does?
Yes, thank you. So my name is Peter Zaitsev. That's what the Z stands for. And at Percona, we help folks to run open source databases successfully, both in the cloud, on-prem, wherever. And obviously, in the last few years, Kubernetes has been a very important and strategic area for us. So we have software, right? Like our own version of MySQL, MongoDB, and Postgres, which typically offers more than upstream, right, of some commercial variants in open source, all right, and have some performance improvement and such, as well as all the suite of services which can help you to be successful.
Excellent. And on to Yaron Haviv, founder and CTO of Iguazio. Thank you for joining us today. Please introduce yourself and Iguazio.
Sure. So thank you. First, I have a long history with Kubernetes. I was actually were one of the first members of the CNCF and participated in all the transition to Kubernetes. Personally, I was attending a bunch of committees, CSI, CNI. I wrote a bunch of papers for CNCF, like the serverless white paper and a few other specifications. So very engaged with Kubernetes from the early days. In Iguazio, what we're doing is sort of a data science platform, which is very automated, fully managed. Most of the components are open source, including our leading sort of serverless, high performance serverless engine called Nucleo, which is sort of used by the way, by NetApp in production for all the NetApp sort of analytic services and predictive maintenance services. So that's in general, and our goal in life is to automate machine learning and AI and make it sort of launch into production using a lot of automation.
Yes, awesome. I love that goal. And last but definitely not least, Sam Ramji, Chief Strategy Officer of DataStax. Tell us a little bit about you and DataStax.
Thank you. I've been in engineering and open source and cloud for pretty much my whole career. I got involved with Kubernetes when I was the CEO of Cloud Foundry, a nonprofit foundation for the leading open source platform as a service. And as we started learning about Kubernetes, realizing that Cloud Foundry probably needed to be rehomed on top of Kubernetes as a developer experience and an operator experience came together. So we contributed the Open Service Broker API from Cloud Foundry, which had a lot of adoption, into the Kubernetes broader ecosystem. I got to work with Craig McLuckie and Ben Hinman on a few different standards and how those could be moved around. Then I was recruited into Google to run the Kubernetes and virtualization and DevOps business as product management vice president 2016 to 2018. Now at DataStax, I'm chief strategy officer focusing on making data on Kubernetes super easy. And so what we do is we have a hybrid database as a service that focuses on Cassandra and now also Apache Pulsar, runs those stateful workloads natively on Kubernetes. And we've open sourced all of that as a distribution called K8s. So a set of Helm charts that gives you the equivalent of fully managed cloud service, but bring your own Kubernetes and run it where you like. So I'm very excited about the decade to come and this movement of stateful workloads to colonize Kubernetes and make it a safer place for state.
Yeah, I'm really looking forward to this discussion. We're going to dive into some topics. I was just biting my tongue while you guys were doing your intros. At NetApp, I know we're seeing customers from every stage of their Kubernetes journey. We're talking daily to customers who are brand new to the ecosystem and those who have been doing it for a very long time. All of you have a long history with Kubernetes. Just big picture, maybe I'll start with Sam. What are some of those trends that you are seeing? What's the 2021 Kubernetes look like?
It's heavily deployed into DevOps environments. It's almost a signifier. If you show me somebody using Kubernetes in production, they are doing CI/CD. They're thinking about operating what they've built. It's drawing in observability. You'll see Prometheus and you'll see Grafana very closely associated with it, maybe Jaeger and Traffic. One of the most interesting changes in 2021 is what was emerging before as a pattern of the service mesh is now a full-blown, early revolution, building on top of Envoy and Matt Klein's work at Lyft, standardizing the service proxy. And now we have a whole profusion of different service meshes corresponding to Microsoft's SMI and others. So that's a way to get all these services working properly. What that's doing is pulling on the whole fabric and asking the question, what's happening with data? So the conversations that I'm excited about and that I've been in for the last several months, and it's really starting to spike in 2021, is what does a data mesh look like? And how might there be a declarative API, like the Kubernetes API is a declarative API for compute infrastructure? How might there be a declarative API for data and storage? So that's the shift that I see as Kubernetes is now an assumption. It's being used in DevOps. It's being used to do service control. And now with that elasticity and growing ubiquity, people are saying, how do we do data here? So that's exciting.
Yeah, and I'd like to kind of throw over to Yaron. You talked about machine learning, and I think that's one of those amazing kind of nice confluences of machine learning and Kubernetes and distributed workloads. What's a trend that you're seeing around Kubernetes and machine learning?
Yeah, so in early days, we focus, I mentioned a lot, CSI, CNI, all sorts of standardization. Also, Sam mentioned some of those in the early days. And as we evolved, we added other things like serverless and service meshes and so on. But I think that the key thing that customers want is not to see Kubernetes, essentially. No one likes YAML files and Docker files and sort of pods and deployments and all of those terms. People want to get things done, and then it's really about how do you run various workloads, just like you're running a service on Amazon, like you're running DynamoDB or you're running Lambda or whatever. You see the cloud provider bringing higher and higher levels of abstraction on top of not even on the services, even on top of the services, you're starting to have higher level abstraction of services. Especially like in machine learning, machine learning sometimes is used to form the services, and sometimes you build machine learning using some of those services and data. And really, what we're getting asked a lot by our customers, because we're providing sort of a managed platform on top of Kubernetes, is we don't want to see Kubernetes, we don't want to see kubectl and all of those things. Okay, and essentially, like a couple of years ago, we built serverless frameworks, and that was wow. It was easy. You just throw in some code, and it builds all the containers and all that. That's not interesting anymore. So we've, in the recent years, for example, we built mechanism where you can actually draw a graph of computation, and it's using the underlying serverless engines to build all of that. So you're moving up the layers of abstraction. Or on the data side, we've introduced recently the concept of a feature store, which is essentially you say what you want to do on analytics, and it builds analytics pipeline for you, which builds the Spark underneath and all those layers. So essentially, people just want to express what they want and get the infrastructure essentially do the stuff for them without knowing about the underlying. And now we're starting to hit Kubernetes on sort of certain edges that it wasn't really designed to do, like how do you schedule workloads and prioritize workloads and do batch scheduling and sort of prioritization and things like that like I'm coming from a lot of background in HPC, things that are sort of common. Oh, how to do batch scheduling and all of that. So now some of the challenges on the infrastructure are moving. Our challenges, like we're seeing failures on Kubernetes on when we're starting to really put big workloads like data analytics and deep learning and all of that. And so on one end, we have the challenge of creating higher level abstraction, making it easy for the users. On the other end, our challenge is to keep the engine working, and make sure it doesn't crash when you hit it with significant workloads, especially data intensive workloads and compute intensive workloads.
Absolutely. And I think that evolution of Kubernetes has kind of come in multiple forms. You've got the evolution of the kinds of workloads and the scale of those workloads and the kinds of performance that they're demanding. And then there's also enterprises who are kind of going, hey, this Kubernetes thing that kind of sounded a bit complicated a couple of years ago, and we run monoliths. Now they're saying, hey, we can run our applications in those in a Kubernetes infrastructure. And one of the really nice parts of that is that there's implications when an enterprise wants to run a workload around hitting performance issues, having security, having lifecycle management challenges, protecting that data, having high availability, and even more, right? So Peter, I'd like to ask you a question. Just thinking about the Kubernetes evolution and the implications of different kinds of workloads and different kinds of businesses and enterprises considering using Kubernetes, what's your thoughts on that evolution, and what are some of the things that we should look forward to when we move into the 2021 of Kubernetes?
Yeah. Well, the first thing from my point of view, right, is Percona, we are database-centric, not the Kubernetes-centric company. I think that kind of puts us in interesting perspective, seeing the evolution before the Kubernetes, right, and even before the cloud, right? And I would say their traditional databases, they often would be one of the most sort of like fearful to adopt the new technologies. Like you would see people running, when virtualization was coming around, people say, well, if you really want to have a mission critical database, run it on a bare metal, right? Then just as they got adjusted to their virtualization, then you see the cloud and Kubernetes coming along, right? And what we see in this case is like really the continuum from of the companies based on their level of comfort. We have folks who are running at this point mission critical workloads on the Kubernetes and having that successfully. At the same time, the other company telling us, oh my gosh, this is not possible, right? It is not possible at all. Kubernetes is not right there. And they have a whole bunch of kind of reasons why they believe that is the case, right? So I think when I talk to companies about the adoption of a Kubernetes or to the teams, it is very important about your motivation, right, and your appetite, right? What is your goal? Do you want to make it work with Kubernetes? And we can help you with that. Or do you want to prove what it's impossible to do with Kubernetes? Because if you want that, well, probably you'll find the rationalization not to do that as well, right? But I think in general, we have a lot of a kind of great trends in Kubernetes when it comes to the databases. Because first of all, Kubernetes was built for their stateless applications, right? And kind of stateless database is a little bit oxymoron, right? If you will, right? Database is where you want your state to be, right? So a lot of those features in a databases, right? Your storage functions, right? It's like an operator, framework, stateful sets, right? They came in a little bit later, but now they are mature and they work fantastically well, really at scale. So from my perspective, from a database state, if you want to run database on Kubernetes, it's pretty much ready for you.
Right. Yeah, I think that's a really good point about the maturity of some of the ecosystem and some of our of the partners in this ecosystem as well. Aside from, I know Percona has a really strong history with databases. What other kinds of workloads are you seeing customers are saying, hey, this makes sense to put into Kubernetes now because we see that there's sufficient capabilities and features and tools that help us be successful. Any others that can come to mind?
So one workload that I think is becoming very evident, and we essentially worked with NetApp to replace Hadoop infrastructure inside NetApp for the NetApp analytic applications with a Kubernetes-based cluster in all the active IQ and all of that, and that was very successful. Because now it's really production ready. No one can say Hadoop is like production ready infrastructure, and neither cloud native. And there's really not a lot of sense to run Yarn and all of that when you have schedulers that are more sophisticated like Kubernetes. And also people understand that all the sort of Spark, Presto, those things that Hive that are dominant on Hadoop, you may want to connect them to like a Jupyter notebook or maybe a TensorFlow or something like that for training that runs natively on Kubernetes. So what makes most sense is to essentially go and put all of those things, migrate them to Kubernetes. There are some challenges we've tackled around how to run all those workloads that were originally designed for Hadoop on top of Kubernetes. But I've seen, there's also some public things that we've seen, and also we have a lot of joint activities with NetApp, with some like tier one financial services and others to essentially replace Hadoop, with its HDFS and all that, with sort of NetApp, NFS, and sort of Trident and all those nice things, and our stack on top, and essentially build a more cloud native big data and analytics and sort of machine learning frameworks. One of the things that reminds me, when we worked with NetApp, which was a while ago, I think maybe a couple of years ago, we started with this. So we had failures in the system. We didn't even know about them. Okay, no one knew about them. Just after sort of looking at the logs, we've noticed why. Because when you have a cloud native system, like a pod can have out of memory, and then it like restarts. And if you decouple state from computation in a nice way, you don't even know about it. Only if you read the logs, you see that the service actually crashed, and there was probably some bug for someone in the system. But that's really the advantage of a cloud native architecture, is that there's always this comparison to sheeps, and herds, and forget the analogy, but
Cattle.
Yeah, cattle and pets. Sorry. So the fact that you treat it as cattle, and one ship goes down, nothing happens, and the system continues to work, is a great advantage to business organizations. The fact that they can do a rolling upgrade of a new service without taking down systems is a great value proposition. So especially for all those challenges today, most of the organizations are challenged with data. Everyone wants to go into more intelligent data, AI, machine learning, to build prediction into their business applications and so on. So Kubernetes could be an essential part of bringing agility into your business, allowing you to build applications, but make it continuous, be able to upgrade them all the way, all the time.
Right. So, Sam, I do want to ask then, I think if you look at Cassandra, which is a distributed database that has been around for a long time, and I look at K8s, Sandra, and I kind of go, well, what are we building these new workloads for? Well, what kinds of workloads are we building these new Kubernetes-ified databases for? Because we can now run persistent workloads in Kubernetes really easily.
Yeah, it's a great question. So I think one of the things that Kubernetes did effectively was it competed with many platforms as a service, right? And when you think about what a platform as a service was trying to do, it tried to give you an app stack. Tried to give you an app stack in a box and conceal most of it from the user and from everybody. So Heroku was kind of the first great example of a platform as a service. Then you have Dockerization of containers, and then you have people putting their Node.js servers in Docker containers, and then they fall over, and how do you scale them? And you end up with Swarm, and then you end up with Kubernetes. So there's a very strong app stack orientation because you have this elasticity. You can scale out, you can scale in, and then you figure out how you can do the networking. Now that app stack semantic this general idea that you can mix and match and have a lot of pieces based on what you're developing and who your developers are is becoming a data stack semantic. So when I see Cassandra, you'll never find Cassandra all by herself hanging out in the wild, right? Cassandra has a lot of friends. Every time I find Cassandra, I find Spark, I find Hadoop, I find Kafka, I find Pulsar, maybe I find Druid, right? To Yaron's point, like you're starting to find Kubeflow because feature stores are starting to creep into how systems are being built. And so you have a team that is paralleling DevOps. The ML Ops team is figuring out how to go and grab a whole bunch of compute just for the training period. So instead of waiting for 20 hours for your training set to come back, could you wait for maybe an hour? Because you're able to grab 20x more compute, easily. So if we back all of that into what's happening is the Kuberization of all these different systems, right? Whether you think of Kafka or Pulsar as a database or not, interest in having those on Kube is high. And connecting that to Cassandra on Kube, connecting that to Spark on Kubernetes, what we found is that Kubernetes, despite the stateful set orientation, it's a pretty hostile environment for state. There's some companies like PlanetScale who are doing a really nice job of taking their project Vitesse about having to scale out MySQL on top of Kubernetes. That's great. One of the challenges is replication. And so what is your replication strategy? Replication starts to bring you into sharding and partitioning. We've learned that if you want to create a coherent distribution of a database in Kubernetes, you need to package it as an operator. And then you need to have a bunch of the things that a human operator might do. You have to have things like anti-entropy repair. You have to be able to rebalance clusters. You have to be able to instantiate new ones and create the right network loads so that you can look at the distributed cluster health. And that's kind of robotic automation of what used to be a DBA's expertise. So what we're trying to do is now pack in enough DBA expertise into a distribution of a database, right? Whether that's PlanetScale and Vitesse, whether that's DataStax and K8s Sandra, so that these can become really, really effective tools for an SRE. So a site reliability engineer, whether that's the title or whether that's the job to be done, is the ultimate consumer of most of these things that are going to be offered to developers. They're all going to be instantiated, installed, managed, troubleshot, observed by SREs. And I think that language has shifted around Kubernetes as well. So these things are becoming stacks of data. They're connecting with each other, and then they're yielding information about themselves transparently to Kube as a control plane for automation and through Prometheus and Grafana so that the SREs can have observability. And that's what we're seeing as the modern data stack.
Yeah, and I definitely see, you mentioned, there's lots of pieces that have to come together, and that's why we have stacks that have been, pre-configured, or here's the best practices, here's how you deploy these, and obviously people want to switch in there and out their own pieces as their businesses need. And so I think what some of the challenges there, or that approach to software development, is taking the limelight, I guess. Nobody wants, like you said, Yaron, nobody wants to care about the Kubernetes and the deployment. So how do you see customers, or how are yourselves in your organizations using automation and machine learning to just get them going faster? So one of those is building stacks. What about the infrastructure underneath? Peter, do you have any thoughts as to how to build maybe a robust Kubernetes infrastructure on which I can then go and deploy my applications?
For us, we operate in this bring your own Kubernetes environment mostly, right? So we do not host things for people in our cloud. And in this case, we do deal with a lot of variety, right? I mean, a lot of people use one of the managed Kubernetes platforms, right? In the top cloud vendors, we also see a lot of traction in the other Kubernetes environments as well. And I think what is interesting in this case, what we see in the modern days with other big players out there, right? When you think about NetApp or IBM or VMware, right? Or Red Hat as a part of IBM now, right? They all have a very Kubernetes story, right? And have their solution adjusted to help people to run that Kubernetes applications in their environment, right? If wherever their focus is, right? So our approach in this case has been meeting the customers where they are, if you will. One of the interesting trends we see with Kubernetes, and I think it's going to make it interesting and challenging with the data, is not to have a database live inside the single Kubernetes cluster, but have across, right? For example, hey, I do not want just to have all my data in a single cluster on AWS, right? I may want to have some of the data in a different cloud, right? And maybe have that automatically done, right, handled. And I think that is something where some work is going down if you want to look more, right? Because if you look at for things inside the single Kubernetes, they have a very robust operator framework, and you can be very flexible, very convenient. Now, if you speak about that kind of like a federated Kubernetes, right, and they have several Kubernetes instances, and maybe they're not the same version, maybe not on the same providers, right, that requires now substantial amount of work outside of that to orchestrate all of it together.
Yeah. I'm smiling because Sam just mentioned how hard state is to replicate. And now we're talking about also we want to replicate the data underneath that, and we want it to be all consistent. And I think these are great challenges for the Kubernetes community as we approach, as we evolve and we grow. So we started this session. I talked a little bit about how partner ecosystems are really important. And at NetApp, we call ourselves the data specialists. And I think in your way as well, you are specialists too. We love working with our specialist partners. How is it important and valuable for customers to work with specialists, people who really understand their data challenges or their AI or their machine learning challenges, just to help their IT teams get started faster or with more success? Maybe Yaron, I'll throw this one to you.
Yeah. So first, I think it's a luxury to maintain your own Kubernetes cluster from scratch. I think only large organizations or ones that want to waste a lot of IT energy want to do it, because working on Kubernetes for like 4 or 5 years now, I think is there are still things that I'm surprised, and I'm you can see I'm writing blogs on like Kubernetes internals and things like that. I'm pretty familiar with Kubernetes from a hands-on perspective, and you keep on finding new challenges and new issues and new bugs, and every time there's a new technology coming and you need to adopt it. So we have customers like insurance companies, banks and others, not to mention smaller companies, that they just can't afford having this level of skills that we have. We have like 20, 30 people that master Kubernetes in the company. You can't find those many people in any organization, and they're like developer and they know how to fix bugs and they know how to find the things in the code. I think you have to. What I see going along is not necessarily everyone maintaining his own Kubernetes, but ISVs will start owning the Kubernetes and essentially create application stacks. And I see it coming from many different ISVs. Yeah, we have Kubernetes inside. So what does it mean, Kubernetes? It doesn't mean that necessarily I'm going to create a Kubernetes distribution. Maybe I'm running on top of GKE or EKS or AKS or any of those services or OpenShift. But essentially, I want to deliver a service to a user. That the service has a nice UI portal that you can, for example, in our case, submit a machine learning job. And by the way, Kubeflow is also managed in our platform underneath. And one of the big things that you can find about Kubeflow is that everyone is thinking that it's really for DevOps people. It's not for data scientists. Okay, because there's no, you need to understand YAML and all that. So how many data scientists know YAML and know how to apply like kubectl and things like that? They know pandas, okay? They know things like that. They know Jupyter. So we see more and more people that essentially are abstracting Kubernetes and building services on top of. Maybe all those services will reside on the same thing. So I assume also DataStack has probably serve a managed service in the cloud, or maybe uses, Databricks has a service in the cloud that probably uses Kubernetes underneath. So what we'll see is more and more sources, and it's not necessarily all in the same cluster, because now that you have especially elasticity like EKS, GKE, it's not that expensive to build multiple clusters. You don't really need sort of a large pool of resources to build everything within that pool of resources. And that's going to the point of essentially cross connectivity between Kubernetes cluster, because maybe maybe Cassandra will be on one cluster, and maybe there will be another cluster with MariaDB or MySQL, and maybe our cluster for machine learning, and maybe SageMaker or another cloud provider service without Kubernetes as sort of something else that's connected.
Yeah, I love that. It's kind of Kubernetes is underneath a lot of the things that even if you don't know it's running there and providing those services. Sam, you were
I like the question that you asked about data, right? Because just because we can say data, we can feel like it's a thing that you can just grasp and you got it. But it's a little bit more like compute and networking, right? Just think about networking and how we're having this call. How many providers are collaborating in order for us to be on this simultaneous digital video? A lot, right? You've got trunk providers, you've got backhaul, you've got last mile, right? You've got the actual service provider that's hosting the call infrastructure. So ecosystems are the name of the shape of the industry now. So you need to have specialist partners, because what you do in data in your application path versus what you do in your machine learning path versus what you do in your discovery path for business intelligence or in your data lake, these are all very, very different fields of data. And then where you put the data, storage. Yes, you store the data, but you need to access it and make different meaning out of it. Stuffing all sorts of things into an object store and making the world full of blobs means that it's incredibly hard to ask questions about the business if you can't unpack it. So if you're going to ask questions, you want to have it structured differently. So I think data partners have a better opportunity now to start to partner on a common backbone with Kube. It's not there yet, but it's coming. And a common control plane, which I think we have to collaborate on so that we understand the layers of the depth of data, whether it's databases, like what we've been talking about with interaction with applications, or whether it's data management, where do I find all the different data, or whether it's storage, where are the actual bits located? Like if you're running the database company, you should care less and less in the future about where the bits are stored. You should care more and more about your ability to use serverless approaches to make the compute cheap and efficient for developers who are trying to access that storage and produce meaning for users. So it's an ecosystem-shaped world, and I think we're finding that Kubernetes has been a great way to collaborate on a big chunk of compute. And now, as data providers, we're all figuring out how do we use that to springboard our own collaboration between the companies on this call and many more.
Maybe another point, I think what really Kubernetes helps us, and probably the other guys here in the call, is that now we essentially have a standard API across all cloud providers and even on-prem, counting some of the on-prem distros. So when I'm coding, when we started, when we had Swarm and Kubernetes and Docker and all that, well, that was really hard. You have to choose now.
Essentially, don't forget Mesos.
To choose now.
Don't forget Mesos.
Yeah,
we had Mesos.
So, but now I know that I have essentially sort of a universal OS, if you think about it, sort of cloud OS, that I can write the same implementation for Google and Amazon and Azure and on-premise. Like that's most important. And also the infrastructure level, with the networking and CSI and all of that. Now I also know how to access resources in a standard way.
That is an excellent way to wrap up today's conversation. I would love to keep talking to you all. You're all incredibly insightful, and I've thoroughly enjoyed this this chat. So thank you again for joining us today for the Kubernetes Day. You can learn more about NetApp and Spot by NetApp's Kubernetes innovation, including all of the newest capabilities, announcements, and products and features at ntap.com/Kubernetes. I hope to see you there, and I hope to see you at the rest of NetApp Kubernetes Day. Thank you, everyone, and thank you to Yaron, to Sam, and to Peter for joining me today. And sharing your wisdom.
Okay, thank you.
Thank you very much.